everyone. So in today's video, we're going to solve a problem in Thermodynamics, Chapter 1, Introduction and Basic Concepts. So here is our problem. The water's absolute pressure is found to be 300 kilopascals at a depth of 30 meters. Calculate the local atmospheric pressure and the absolute pressure in an 8-meter deep liquid with a specific gravity of 0.96. What is pressure? So, it is a measure of the force exerted per unit area on the boundaries of a substance or system. So here we have the unit of pressure in SI. Pascals is equals to Newton per square meter, and in English we have PSI or pounds per square inch. So here we have the formula for pressure. So pressure is equals to force over area or rho GH. So rho stands for the density and g is the constant gravitational acceleration, which is 9.81 meter per square second, and h is the height or depth. So here we have the given. The absolute pressure is equals to 300 kilopascal, height A is equals to 30 meters, and height B is equals to 8 meters, and the specific gravity is equals to 0.96. So find the atmospheric pressure and the absolute pressure at the specific gravity of 0.96 at a depth of 8 meters. First, we are going to solve for the atmospheric pressure. So we have here the formula for the getting the atmospheric pressure. We have here the absolute pressure is equals to atmospheric pressure plus gauge pressure. So deriving this equation, then we have atmospheric pressure is equals to absolute pressure minus gauge pressure. So we have the value for absolute pressure, but we don't have the value for the gauge pressure. So first we are going to solve for gauge pressure. So we already know that the formula for pressure is equal to force over area or rho GH. So note the density of water is constant. That is 1000 kg per cubic meter, and the height, which is given at 30 meters, and the acceleration due to gravity, which is constant 9.81 meter per square second. So here we have the solution. So plugging in our given, so 1000 kg per cubic meter times 9.81 meter per square second times 30 meters, so that would give us the value of 294,300 pascals. So converting that into kilopascals, we are going to divide it by 1000. So that would give us a value of 294.3 kilopascals. So now we have the value for gauge pressure, 294.3 kilopascal. Plugging in that into our equation, so 300 kilopascals minus 294.3 kilopascals, so that would give us a value of 5.7 kilopascals. So that would be our atmospheric pressure. So next, we are going to solve for the absolute pressure at specific gravity of 0.96 at a depth of 8 meters. So we already know that the formula for absolute pressure is equals to pressure plus gauge pressure, but we don't have the value for gauge pressure. So note, we have here a given 8 meters at height B, specific gravity is equals to 0.96, and G is equals to 9.81 meter per square second. But the value for the density is unknown. So we're going to solve for the value of density first. So we have here the formula for the specific gravity, which is density of the fluid divided by density of water. So deriving that equation, so density of liquid is equals to specific gravity times this density of water. So note that density of water is equals to 1000 kg per cubic meter constant, and the specific gravity, which is given 0.96. So the density of the fluid is equals to 0.96 times 1000 kg per cubic meter. So the density of fluid is 960 kg per cubic meter. So now we have the value of the density of the fluid. So now we could get the value of the gauge pressure. So plugging that into our equation, then 160 kg per cubic meter times 9.81 meter per square second times 8 meters, and that would give us a value of 75,340.8 pascals. Converting that into kilopascals, that would give us a value of 75.3408 kilopascals. So now we have the value of gauge pressure, and plugging that into our equation, which is absolute pressure is equals to atmospheric pressure plus gauge pressure. So 5.7 kilopascal plus 75.3408 kilopascals. So the value of the absolute pressure is now 81.0408 kilopascals. So that is the value of the absolute pressure in an 8 meter deep liquid with a specific gravity of 0.96. So that would be all, and thank you for watching.